So we're looking at section 9.2, multiplying and dividing rational expressions. So we want to be able to understand the rational expressions from a system that's closed under addition, subtraction, multiplication, and division by a non-zero rational expression. And we want to be able to multiply and divide these rational expressions. So if we use the facts that we know about multiplying rational numbers to determine how to multiply rational expressions. So how would we multiply 4 over 5 times 5 over 6? Well, we multiply 4 times 5 to find the numerator of the product, and then multiply 5 times 6 to find the denominator of the product. So 4 times 5 is 20, and 5 times 6 is 30. So to simplify, we factor the numerator and the denominator. So 20 breaks up into 2 times 5. 60 breaks up into 2 times 3 times 5. So then we cancel out the common factors in the numerator and the denominator to simplify the product. So those 2's will go away, the 5's will go away, we'll be left with our simplified fraction 2 over 3. So based on the steps used for multiplying rational numbers, how can we multiply the rational expression? We're going to multiply across, multiply the numerators, multiply the denominators, and then simplify. So multiplying rational expressions is similar to multiplying rational numbers. Likewise, dividing rational expressions is similar to dividing rational numbers. How could you use the steps for dividing rational numbers to divide rational expressions? You do the same thing you would do. So you would multiply by the reciprocal. So instead of dividing, we multiply by the reciprocal, and then we'd follow those steps that we just talked about for multiplying numbers. So to multiply rational expressions, multiply the numerators to find the numerator of the product, multiply the denominators to find the denominator, then simplify the product by canceling the common factors. Note that the excluded values of the product, which are any values of the variable for which the expression is undefined. So we always want to look for domain issues. Those have to be excluded values because our denominator can never be 0. That's when we have a problem area. So here in the example, they factored the numerators and the denominators. That's the first thing you should always do is factor. Then multiply the numerators and multiply the denominators. Then cancel out the common factors to get your simplified answer. But you also need to look for the values that make the expression undefined. So you have to take the denominator of your original two functions as they are separately and find each of those excluded values from those. So here in this example, first thing we want to do is factor. So we've got x squared minus 8x, so we can factor out an x. And in the denominator, our function will factor to x plus 3, x plus 5. And then factoring a 7 in the other piece here, we'll end up with x plus 5 in our numerator, and then keep that x plus 8 in the denominator. So all we're going to do then is multiply the numerators and multiply the denominators. So 7 times x, and then times the x minus 8 times the x plus 5. And then the 14 times the x plus 3, x plus 5, x plus 8. So now we can cancel out the common factors. So the 7 and the 14 will each divide by 7. So that 14 in the denominator is going to change to a 2. And then the x plus 5s are going to cancel. So now what's left in our numerator, we've got an x and an x minus 8. In our denominator, we've got the 2, the x plus 3, and the x plus 8. So next we need to determine what values make the expression undefined. So this is based off of our denominators up here when we had it factored. So the denominator is 0 when x equals negative 3 and when x equals negative 5. And then in the second piece here, the denominator is 0 when x equals negative 8. So that means those are all of the undefined values. The excluded values would be negative 3, negative 5, and negative 8. So if we want to multiply these rational expressions, first thing we need to do is factor. So x squared minus 9 will factor to x plus 3, x minus 3. That's a difference of squares. And then we still have that x minus 8. I'm going to go ahead and just multiply everything right at once here. So x squared minus 5x minus 24, that factors to x minus 8, x plus 3. And then the 2x squared minus 18x, we could factor out a 2x, and then we're left with x minus 9. So now we can look for the things that will cancel. So the x plus 3's will cancel, and the x minus 8's will cancel. We'll be left with x minus 3 over 2x times x minus 9. When we think about the excluded values, if we set each of these factors in the denominator here equal to 0, those would be our excluded values. So x can't be 8, negative 3, 0, or 9. Okay, number 3 here. So first thing we want to do is factor as we can. The first fraction there is perfectly fine. So looking at our second numerator, we can factor out a 3. We'll end up with x minus 9. And then in the denominator, we just have the x minus 9, x plus 1. So canceling here, those x minus 9's are going to go away. That's the only thing. So in the numerator, we're left with 3 times x over x plus 1 in the denominator. Thinking about the excluded values, those are anything that's down here. X can't be 9, x can't be negative 1. So that's multiplying. We're actually going to apply this when we do our dividing. So to divide rational expressions, change the division problem to a multiplication problem by multiplying by the reciprocal, then follow the steps for multiplying rational expressions. So that's the key thing here. We're going to multiply by the reciprocal. We have to be extra careful, though, when we're determining what values of x make the expression undefined. We have to look at the original functions as they're given to us. So we'll look at this x squared piece here, and then we'll look at the x squared plus x minus 2, as well as once we have taken our reciprocal. So we're going to look at a couple extra pieces here. So when we try this one out, so we've got 6x over 3x minus 30 divided by 9x squared minus 27x minus 36 over x squared minus 10x. So the first thing you do is you multiply the reciprocal. So we got to flip our fraction. We'll get x squared minus 10x in the numerator here, and the 9x squared minus 27x minus 36 in the denominator. So now we can factor. So we'll end up with 6x over 3 times x minus 10. And then we'll have an x times x minus 10 in this numerator. The denominator, we can factor out a 9. We'll be left with x squared minus 3x minus 4. So that is the piece that's going to factor to become x plus 1, x minus 4. So now we can do that multiplication. So we'll get 6x squared times x minus 10. We'll get the 27, x minus 10, x plus 1, x minus 4. So now we can look at any cancellations here. So the x minus 10s are going to go away. And the 6 and the 27 will simplify. Those are each divisible by 3. So if we divide each of those by 3, we'll end up with 2 and 9. So in our numerator, we'll have 2x squared. Denominator, we'll have 9, x plus 1, x minus 4. So we have to think about all the different denominators that would have a problem. So the 3x minus 30 would have a problem when x is 10. The x squared minus 10x is going to have problems where x is 10 and x is 0. Next one will have problems when x is negative 1 and x is 4. So those are all of our excluded values: 10, 0, negative 1, and 4. So you have to look at multiple places. You have to look here and here and here for all of the problem areas.